Hi friends, welcome Saturday morning with full enthusiasm, passion, and love. The question on this screen is about component vectors. A block with a certain weight is on an inclined surface. We are asked to decompose the weight vector into two directions, one parallel and the other perpendicular to the inclined surface. Let's answer this question easily. Before going any further, just draw the weight as a vertical arrow downwards as W. Weight is a vector quantity. Vector quantities can be resolved into several vector components. What is certain is that when all the vector components are added together, the original vector will be obtained. The first component is a vector that is parallel to the inclined surface. Just draw a vector starting from the origin of vector W, which coincides with the inclined surface line. We can estimate the length of this vector. It doesn't matter. This is a vector that is parallel to the inclined surface. The second component is a vector that is perpendicular to the inclined surface. Like the previous process, draw a vector that starts from the starting point of the vector W that is perpendicular to the inclined surface. Don't think about the length of this vector. Certainly, vector W is the diagonal of the plane of the box formed by the two component vectors. Now, we will analyze the angle of the vector. The angle of the inclined surface is 60 degrees. Consider this triangle. It is a right triangle. Thus, this angle is 30 degrees. Using the concept of trigonometry, the cosine of 30 degrees is W parallel over W. From here, W parallel is equal to W cosine 30. In the question sheet, the value of W is 100 newtons, and the cosine of 30 degrees is half the root of 3. So W parallel is 50 root 3 newtons. Next, the sine of 30 degrees is W perpendicular over W. From here, W perpendicular is equal to W sine 30 degrees. Plugging in the values of W and sine, W perpendicular is equal to 50 newtons. This is the component of the weight vector asked by the question. Happy learning, everyone.